Hello, welcome to a video explaining the QCAA Physics 2023 paper, Multiple Choice Solutions. Alright, well, today you'll need a couple of things. So first of all, you'll need, maybe not that, probably not that. Do you have a calculator of some sort? Abacus? No. Or graphics calculator, they're allowed on physics as well. You also need, along with your calculator, your formula book. Let's go through the solutions. So I'm going to look at this for the first time. It's like one of those box unveiling videos on YouTube, except a bit more nerdy. It's an exam. Okay, well, let's have a go. First time, what have they given us? A speed of light question. So question 1. An object is unable to accelerate to the speed of light because... Okay, so this is all to do with relativity. A length contraction will change the height of the object. Well, that's wrong. Length contraction changes the length. Time dilation will decrease the velocity of the object. That's not correct. The object will gain infinite momentum. So if we think of the momentum formula, momentum is getting bigger and bigger and bigger. So C is correct. D, the inertia of the object will decrease. Well, the object is just accelerating to the speed of light. So inertia is just an object will continue doing what it's doing, so it's not going to decrease. So D is incorrect. So the correct answer is C. Question 2, photons. So this is part of our standard model. I did make a summary video on this if you want to check it out. But photons are one of the particles in the 4 fundamental forces. So photons are part of the gauge bosons. That's what they are. And they are part of the electromagnetic force. So they are a gauge boson and they exhibit wave characteristics. So A is correct. B, particles that only travel in a medium. Photons don't need a medium. So if you think of the electromagnetic coming off the sun, it doesn't need a medium to travel. Mediators of the weak nuclear force. C is incorrect because they are the electromagnetic force. And D, photons are not a lepton. Yeah, so that's incorrect. They are a gauge boson. All right, question 3. All right, we have a calculator question. So get out your calculator. We've got a wire, current traveling through it, and we need the magnetic field strength at X. So formula book is helpful as well. Magnetic field strength. So if you didn't know this, magnetic field strength is indicated by B. So it's one of these two formulas. They've given us an I and they've given us an R. So that would be this formula here. So we're going to type this into the calculator. We also need mu0. So type that into your calculator. And so the radius, we need it in meters. So we're going to have to turn this into meters. So divide by 100. So the answer is either A or B. Now we have to figure out, is it out of the page or into the page? So don't forget your right hand rule. The thumb is pointing towards the arrow and it's coming out of the page. So fingers pointing towards you as we point down. So X is out of the page. So it's A for question 3. Question 4 is Kepler's third law. Okay, so this is a bit mean. You have to know Kepler's laws. So 4A, describe the elliptical orbit of planets. So that's Kepler's first law. B combines Newton's first law of motion with uniform circular motion. That is incorrect. C equates the area of the arc sweep of a planet. So area, that's all about Kepler's second law. So there's no area in the third law. And D describes the relationship between uniform circular motion and the law of universal gravitation. That is Kepler's third law. And there's, if you look on the formula sheet, this is basically Kepler's third law. All right, question 5. Young's double slit. So, very famous experiment. It was an experiment. Basically, before that, scientists thought light traveled as a particle. Double slit experiment showed light traveled as a wave. Okay, so that's what we're looking for. So A says behaves differently in different frames of reference. So this has nothing to do with frames of reference in the slit experiment. So A is incorrect. B shares characteristics with mechanical waves. That's what it discovered. So B is correct. C is a longitudinal wave. No. And slit experiment, it didn't find that it acts like a particle. All right, question 6. An object of mass that many kilograms. So we've got a calculated question. We've got a mass. We've got a time. And it's going around a semicircle. And we want a force. So we go back to our formula sheet. Our best friend, gravity and motion. So we've got force here. So this is the one we've got to use. But first we've got to find V. So we're typing in 2 pi r, or r is the radius, so we're going to divide by 2, so we get 80 meters, that's the standard units, divided by, now this is the trick, t is a full revolution, we've got 25 seconds is a half revolution, so the full revolution we're dividing by 50 seconds. So that's our V. And now we're going to type V into this one. So that gives us not A, it is B. All right, 7. An electron and positron can annihilate into a photon. Ah, great question. So we've got an annihilation question and it produces another electron and positron. So, does the total mass decrease? No. Photons are massless. There's no change in mass. So, A is incorrect. We've got electron, positron afterwards. So, no change in mass. B, fewer baryons will be produced. Baryons, they have 3 quarks. And, yeah, this isn't to do with baryons. So, that's incorrect. C, the lepton number does not change. That is correct. So we have the same leptons, the start and end. And D is incorrect. So the particle number doesn't decrease. Nothing gets destroyed. Question 8. So we have a frequency of light and we have a work function. So we need to determine the kinetic energy. So back to our formula sheet, calculator question. So we've got kinetic energy here, hf minus w. H is Planck's constant. There's Planck's constant. So we're going to do Planck's constant times F minus W. Planck's constant times F minus the work function. Okay, so we've got the kinetic energy in joules, but you can see the units here are in EV. So we've got to divide our answer by something to get it into EV. So what could we divide? What's on the formula sheet that could help us here? What's this little number? So we get A as our answer. So 8A is the correct answer. So hopefully you didn't get stumped by C, which is This would be correct if they had a J there. All right, question 9. We have a magnet question. So we've got a magnet, solenoid, 5 turns, and then a cross-sectional area, which produces an EMF. And then it says calculate the EMF if the same magnet passes through another solenoid 3 times as many turns, half the cross-sectional area. This looks like it's a ratio question. So the first thing you should do is jump to your electromagnetism box in your formula sheet. We've got EMF formulas here. We've got N, which is the number of turns, and A is the cross-sectional area. So it says the same magnet 3 times as many turns. So the EMF is proportional to the turns. If the turns triple, the EMF is going to triple. And then the cross-sectional area has halved. Cross-sectional area is proportional to EMF. So it's first going to triple because of the turns, and then the EMF is going to half. So we just have to go 0.75 times by 3 divided by 2. And that will get your answer, which is B. Question 10. A black body at a temperature of that many Kelvin produces photons across a range of frequencies. Calculate the frequency at which the maximum number of photons is produced. So we've got some numbers again. So we're going to get back to our formula book again. So we've got our quantum box on our formula sheet. And this is where this formula comes in. So I think it's pronounced Wien's constant, because I think they're German, or he's German. T is temperature in Kelvin. You can find his constant here. So typing it into the calculator. So we calculated the wavelength. Okay, so if you got to C, you calculated the wavelength. And so we need to use this formula here to turn it into frequency, because the question's asking for frequency. So you do V divided by wavelength. So what's V? It's talking about photons which travel at the speed of light. So 3 times 10 to the 8 divided by the wavelength you just calculated. So the answer is A, that is the frequency. All right, question 11, we've got a Coulomb's law question. So Coulomb's law is on the formula sheet. It's under electromagnetism. Basically, this is Coulomb's law right here. So force is proportional to the charges and inversely proportional to the distance between the charges, R. So we have to kind of look for this. So an electromotive force in a circuit may be induced through changes in the magnetic flux. So part A is all to do with flux, and that's not Coulomb's law. Part B, charged particles moving across magnetic field lines. This isn't Coulomb's law. A change in the electromotive force is opposed. No. Like electric charges repel one another. So we've got charges in here, and that's what Coulomb's law is about. So it's describing the observations of electric charges. Q and Q are electric charges. So D, 11D is correct. Question 12, what is the consequence of symmetry in particle interactions? So we're looking at the standard model, Feynman's diagrams. In an interaction between particles, we need to, it shows that momentum and energy are conserved. So A is correct. So B isn't correct. So the charges on the particles won't always be different. They can just be the same after the interaction. C is not a consequence of symmetry. So antiparticles do appear to travel back in time, but it's not a consequence. D, the mass does not decrease, so that's incorrect. So the answer is A. Question 13, a magnet moving through a coil of wire. So this should immediately bring to the front of your mind Lenz's law. This is helpful in this. So moving through wire will induce a current with a magnetic field. It's not parallel to the electric field. It opposes it, so it's opposite in the direction to the change in flux. So B is correct. It's not inversely proportional to electromotive force. So if you look at these ones here, there's no flux proportional to EMF, flux proportional to magnetic field. So they're not inversely proportional. And D, that will continue to fluctuate once the magnet is removed. So once it's removed, it's done. So if you keep pulling the magnet in and out, it will fluctuate, but once the magnet's out, it's done. So that's why B is correct. Okay, question 14. An electron is best described as, okay, so you can see ABC has lepton, baryon, meson. So an electron is a lepton. They are, a single quark. Baryon is 3, meson is 2, so it can't be B or C because it's not a baryon, it's not a meson, so it's going to be A or D. So A says lepton with a larger mass than a positron. So you need to know the masses of electron, positron. Electron is not heavier than a positron. D, particle whose interactions can be mediated by photons. So you need to know about the 4 fundamental forces. And so the electromagnetic force is what's related to a photon, and an electron can be mediated by a photon. And you can see this in experiments. So D is the correct answer for 14. 15. 2 objects experience a gravitational force F between them. Calculate the magnetic force acting between the objects. If the distance between them was doubled and the mass of one object was doubled. Alright, so are there any formula sheet formulas? So we've got this formula here. The distance between them, R, was doubled, and one of the mass was doubled. So you've got 2m on the top, and you've got 2r squared on the bottom. So it'll be 4r squared. So it's going to be halved. B is the answer. Question 16. Relativity, trains, everybody's favorite. So this is the barn paradox. So you've got something heading towards a barn, like a stick, same length as the barn, but its length is contracted, so it will fit inside the barn. So D, be shorter than the tunnel. That is the correct answer. Question 17. The half-life of an unstable subatomic particle is measured by a stationary detector to be longer when its velocity approaches the speed of light. This is because the particle... Question 17. It's great to think about the muon experiment. Dr. Walding has talked about this in his videos. So time acts differently depending on the reference frame. So the subatomic particle in this question experiences time differently to the detector because they're in different reference frames. So A isn't correct. It's not really explaining why this is happening. B, it's not in the same reference frame as the detector. They're in different reference frames. And D, that doesn't answer the question. You can observe things at relativistic speeds. So C is correct. All right, we're down to our last 3 questions. So an object is placed on an inclined plane with a slope. So inclined plane, so we've got to figure out the resultant forces. It's got a frictional force which acts up the plane and 40 newtons. And we've got to translate the weight, which is perpendicular to the earth. So the weight is 20 kilograms times 9.8. Friction is 40 up the plane. So we just have to figure out the resultant. So we're going to have to turn this weight force into a weight force going that direction. So we're going to have to multiply it by sine 35. Okay, if this is 35 degrees, this is 35 degrees here. This force is opposite the 35 degrees. So that's why we're using sine 35. So let's figure out that weight force first. 9.8 times 20. So that's the weight in newtons. Now we're going to figure out the weight force acting down the plane. Okay, so that's the force acting down the plane. 112 newtons. We're going to subtract the 40, the friction going up, and that gives us our resultant, our net force. And now we need to divide that by 20 kilograms. So you do force equals mass times acceleration. Divide the force by mass and you get the acceleration. So the answer to 18 is A as the acceleration, 3.6. All right, question 19. Electric field strength experienced at a distance of that many meters from a helium nucleus. So we have a distance away. In a helium nucleus, there's 2 electrons. Looking at our formula sheet, what could be useful here? So this formula, these 2 formulas here. So we're looking at here, this constant divided by r squared, and Q is the charge of an electron. This constant into the calculator, and then divided by the radius, where that got the constant divided by r squared, we need to multiply by Q. And there's 2 electrons, so we're going to multiply it by 2. So the answer is C. Okay, so to do question 20, I think it's possibly the hardest. We've got to get a change in energy level. So we're going to use the formula here. So I'm going to do Planck's constant times by the frequency. And we've got to convert this to EV. So that means we've got to divide by 1.60 times 10 to the negative 19 joules. So this bit here. Because this will give it in joules. So if we divide by that, that'll convert it to EV. So this will give us a change in EV, or an energy change in EV. So now we need to type this into the calculator. And that will give us our change in EV between the 2 energy levels. So now we just have to look at the graph. It's going 3 to 4, which is D. So D is the correct answer. So well, thanks for watching this video. I hope that was helpful. Don't forget to check out my 2022 answers. I just want to dedicate this video to my 2023 physics class. Thanks for being such a great class. We did have some good times together. All the best with your studying, students.